Okay, so the Miller Institute for Learning with Technology is a California 501c3 nonprofit. I founded it in 2000. I'd been doing consulting with schools on educational technologies for a couple years before that. Really what I wanted to do was reach out to the communities that were underserved in having good access to technology. So we incorporated it as a nonprofit so that we could be measured by basically, are we changing the world and making a difference? We help schools write a technology plan. We help schools apply for E-rate funding to get their internet and that sort of thing. We run professional development for teachers, and we try to help teachers think about changing their role, not just how to operate the device, but how it changes what you do in your classroom. And of course we offer summer camps and after-school programs with kids, and we do tactical support as well. So if it involves technology and learning, and it doesn't involve selling you something, then we probably do.
So talk about the Lego Robotics camp.
Well, one of the things that we have the most fun doing, that we get to do in the summertime primarily, and some after-school programs, is using robotics. And the best one we think to start with currently these days is probably the Lego Mindstorms. I personally love robotics because it's a vehicle for teaching kids computer programming, and I think the important ideas behind computer programming that is much more motivating and makes that connection between the concrete and the abstract in a way that very few other things can do. I've taught programming to middle school kids where you're doing things on the screen and so on, and it's just not as exciting. It doesn't make it as tangible. I think you can use it to cover many different things that would be sort of core content, standard sorts of things. For example, when we have kids writing a program to traverse a maze, they're thinking about the geometry of it. They're doing a little bit of algebra in terms of, well, if I turn the motors on at full speed for 500 milliseconds and it's only making it 3/4 of the way to the end of that run, then how much do I need to change that? So they're not saying, why do I have to learn this? They can't wait to run back and make the edit to their program. There's a lot of kind of deeper, what I would call the powerful ideas, the Seymour Papert, George Polya kind of ideas that we think kids get out of it that I think are not given enough attention in school. It's the things about how to be good at solving problems, being resourceful, being able to be persistent when it doesn't work the first time. I mean, I actually prefer it when their program doesn't work the first time and they go through that, oh my God, I'm stupid, my robot will never work, and you get to say, no, it happens to everybody. Let's talk about this, let's look at it. Did you look at, well, maybe the wires are plugged in backwards, or maybe there's a line missing from the program, or in the case of the Lego programming environment, it would be one of the programming blocks missing from the flow chart. When they do get it, they feel this sense of empowerment, this sense of, oh wow, I'm smart. And then of course when parents or grandparents come to visit and they show off these amazing creations that they've made, they just beam with the pride of creation. It's an opportunity for kids to build something that they're passionate about doing. It's authentic to them. They care about it, and they can see every night on the news that robotics in itself, even as a career area, is something that can be important. But I think what's important, what they're really getting out of it, is much deeper than whether they ever become a programmer or do robotics. There's the math and there's the problem-solving skills that I think is really what matters.
Miku, I done it! I done it!